So now that we have our recoil, let's also add some sway into the mix. So we will have a general, yeah, we will basically have most of what we're ever going to need as well. Now we have cam parent and recoil parent. We kind of want to use, well, we'll just add sway. We'll see which object we should use. Maybe we add this under, and maybe we split our weapon. Let's see. Maybe weapon can go under camera parent event. And we can assign, well, okay, let's just create another empty object over here, which is going to be the weapon holder. And we're going to assign the weapon holder to this because the camera is going to be moving directly where we want, and then the weapon holder will actually follow. So let's open up our FPS handler and let's assign the FPS handler. Let's assign another transform for sway or weapon holder. And okay, let me check one thing. Now what we basically going to need is we want to have the delta rotation of both our tilt and our y-axis. Okay, so we can move this up and down or rotate it and so on. So how do we find our delta tilt then and our delta rotation? Let me check one thing. So let's go and expose a few things onto our controller. Now we don't have a need for them to be shown in the inspector, but we kind of want them to have access to this. Now there is actually, if you search other tutorials and even I did the same mistake in the past, most just do sway based on input, which is very wrong, because then you're depending into storing inputs. If you were ever going to recreate it, you will be, yeah, you will basically need to store your inputs and all this stuff. So that means if you're trying to sync it across the network, then you just make your messages much bigger. So no, that's the wrong way. We are going to do it the correct way by calculating delta angles and delta tilt. Now these are exactly the same thing but for different game objects. That's why we split them up. So I'm actually going to also use, actually no, we don't need to limit the angle yet. And then inside our handle rotation, after we have done all of this, we're going to need to know our tilt. So our camera transform dot local Euler angles dot x minus, we need to be storing our previous rotation tilt, so minus last rotation tilt by x, and if our tilt is higher than 180, then our tilt should be minus 360. So we're going to limit our tilt and wrap around it, so we are on the barrier of 360. Okay, then last rotation tilt now will be the camera transform dot local Euler angles, and then our delta tilt is basically the tilt we have right now. Let's do the same thing for our angle. Then transform local Euler angles dot y minus last rotation angle dot y. Then the same thing over here, but with the angle, and then actually last rotation angle equals transform.local Euler angles, then delta angle will be now our new angle. Okay, so now I can access the delta tilt and delta angle from my FPS handler script and then apply that angle into my weapon. So let's go to our FPS handler. Yeah, okay, we have a handle shooting. I think we can just do this inside our tick. And maybe it makes a little bit more sense if we allow the weapon itself to control the sway. So let's do public float sway limit. I'm just going to use one value. If you want to split it for up and down, just do a second value over here. So basically all I'm going to do is public void tick from the owner. Let's see, and let's think. We kinda want to, yeah, okay, that's not going to work. Okay, we're going to have to be passing back the value, so we'll just use it on the FPS handler then. So void handle sway float delta controller C. So we need to keep track of the angular range we are in right now and the tilt range and the sway speed, which also makes sense if we have it on the weapon then. Okay, so let's drop this inside here. Handle sway delta and controller. Then let's see, okay. Okay, so let's get the tilt from delta tilt. Then we're going to clamp that tilt to clamp between our current weapon dot sway limit and current weapon dot sway limit. Of course, this needs to be negative. Then we need to make this into a percentage or a target percentage. So we're going to get the tilt, subdivide that by our sway limit multiplied by 2, and we're going to turn that tilt into 0.5 f. Then our new tilt range is going to be mathf.lerp tilt range. The tilt we want to get delta by current weapon dot sway speed. So what does this all mean? This is a delta tilt, so basically the rotation we did for this frame. This makes a smoothing, so basically this gets you a percentage between your tilt and sway limit multiplied by 2. I don't remember why I did this. I think I could just add the sway. Yeah, that kind of confused me. Anyway, let's keep this for now and let's actually test it. I think it's more important we test it right now, and we'll change the values as we go. So weapon parent or weapon holder, I guess, dot local Euler angles, then e dot x is mathlerp the that's why. Yeah, we're doing a range. Yeah, this calculates the percentages. So from 0 to 1 based on the sway limit, and then we are lerping between the two sway limits. So current weapon the sway limit to current weapon dot sway limit minus. Okay, because of course when we're moving we want to be moving the other way, and then we assign the tilt range, and then we of course we need to add it back to the E. So let's go and check this out. Let's see if we need some fixes. On our weapon we have sway limit 15 and sway speed at 8, so we should get some movement. Okay, and we have our sway, but it's on the tilt, of course. So let's add the left and right then as well, but it does work as expected. And which means we could just do the same thing now for the angle, delta angle, and angle equals mathf dot clamp angle, then current weapon dot sway limit, current weapon dot sway limit, float p angle by current weapon dot sway limit. I think we could probably just skip the entire. Well, for now it doesn't matter, but we could probably remove or make this into its own component and use the used on an object. But for now, I guess it doesn't matter. We only want this for the weapon. Angle range between the percentage of the angle. Then we have delta multiplied by current weapon dot sway speed. Then on the e.y we'll do mathf dot lerp current weapon dot sway limit, current weapon dot sway limit, angle range, and this needs to be minus. Okay, and there we go. We have our component. I don't like the s2e6 a lot for the weapon, but I'm not sure what forces that, so let's close. Let's say speed iterations, let's just set multiplier to 0, see if it's coming from that. Can also control the weapon holder. Okay, that might just be the camera. Like this feels fine, but let's see, weapon holder is this. Okay, let's say we remove the seeker. Yeah, seeker was coming from the sec was coming from this. This much more clear. So let's see. Let's do iterations like even lower, like just a few pixels. Should be better. Yeah, it's much better. It just seems like a sec, and add all the VFX for this, and then it should be looking correct. Now, as you can see, sometimes we are actually shooting our own guy. We can fix that on a later part. Okay, so yeah, that's basically it for this one as well. we now have recoil, we have sway, which is very important to make this look authentic. Now you see the weapon clips. Basically you can just go to your camera and set clipping planes to 0, and then it won't clip anymore, but we're going to do a double camera setup anyway, so it doesn't matter. Let's add one more thing just to know that everything is aiming correctly. I'm going to add a canvas. I'm going to make this red, or just keep it white, I guess, and add an outline. Let's add knob, and let's make this tiny. Okay, just so that we know that we have somewhere to shoot at. And you see that I hurt myself over there. Awesome. So that's also sway then. And we can even just start adding some yeah, I think we just go with fixes, and we can even add some art and some stuff like that. So I'll see you on the next one.